Hello, everyone. Good evening. I hope you all can hear me well. So great. So again, very good evening and welcome to our continuous testing meetup online. I am Shuqi Jiang, so I'm based in Munich, and it's really my honor today to host this meetup. And I hope you will all enjoy your time with us tonight. So let's get started. We all know that this meetup will not happen without the sponsor support. So I would like to thank our sponsors, South Labs, Trendic, and TUI Amusement. So South Labs, I hope you all heard of it. So South Labs provides excellent testing infrastructure services, and they have also other brilliant products to support testings, and they have very good technologies. And Trendic, so we organize the big event in Germany every year in Potsdam. It's called Agile Testing Days. It's a really big event that a lot of famous professionals in testing areas will all come to Potsdam every year. Please visit this year. So Trendic also have a lot of consultants. So we, like me, I'm also a consultant from Trendic. So we support customers in different projects to help the customer to overcome the quality challenges. And TUI Amusement, with TUI support, we can have this Zoom account to do recording, so we can share with you afterwards. And if you miss anything, you can also watch it later on. So thanks again, the sponsors, for the support. So like I mentioned, we have recorded the meetups and also all the past meetups. So if you miss anything, please feel free to visit the website. There you can find all the meetups from the past. Let me check if I forget anything. Before we start, I have a side note. So if you have any questions during the meetup, please write it down or just post in the chat. I think Nick will answer it as soon as he sees it, or if the time is suited. So please feel free to write down all your questions in the chat. We will also have an open question session at the end of the presentation. So that's the most important part. So today we have Nick here. He's based in Cambridge in UK, and welcome, Nick, to our community. Is this your first time to join the meetup with us?
It is, yes.
Yeah, perfect. So thanks for your interest. So before start, would you like to say some words about yourself so we have a little bit better picture from you?
Hi, I'm Nick, based in Cambridge, as you said. I'm a full stack developer. I've been writing software for probably over 30 years now. I only tend to work in software startups and small companies, which are often quite short of cash, and certainly to scratch one of those itches was why I created Cykubed in the first place. And today I'm going to talk about Cykubed, why I built it, what it is, and I'm going to go through a demo. I'll actually kick the demo off fairly early on in the talk because it can take some time to run. But as you said, feel free to ask questions at any time, and I'll answer them there and then if you have them. Apart from that, I'm ready to go.
Yeah, perfect. Thanks a lot, Nick, for your short introduction. I think you covered pretty much all the information that I was about to say. So I will give the stage to you, and please take over the screen and enjoy the evening with us.
Yeah.
I will stop sharing.
So, can see the slides? Very good.
Yeah.
Excellent. So as I said, I'm going to talk about Cykubed today. Cykubed was my project I built myself to solve a particular problem to do with Cypress and automation and using Kubernetes. So let's go straight in. I'm sure everyone here kind of agrees with this statement. That's kind of the raison d'etre of these kind of meetups is the code isn't finished until you've proven it's working. And by that, it means you have a test that runs reliably and reproducibly. And ideally, doesn't involve a human because humans are expensive and fallible. So we really want to automate as much as we can. That tends to be uncontentious with backend. Everyone assumes that when you write backend code, you write a regression suite, you automate it. It tends to be quite straightforward. The reason we automate our tests just is because we catch errors earlier. We get fast feedback loops, so our integration branches always work. The earlier you catch the error, the less damage you can cause. Your test helps document your code. If you have a full regression suite, deployments are less scary, and you can refactor and upgrade packages again with much less risk. Now I know this is everyone kind of here will understand this, but I think sometimes it's worth repeating this, particularly sometimes when you're trying to get buy-in to say, look, why would I spend time automating this? Well, this is why. But often I found, particularly in startups, but often even in bigger companies, that regression suites, front-end regression suites, actually are quite rare. It's not necessarily the norm that companies build and automate tests for their front ends. And it's always been a bit of a mystery to me why, but I think probably most of the reason why is because the tools used to be very painful. And before Cypress and Playwright came along, writing UI tests was quite difficult and error-prone and flaky and just generally not friendly. While you've always been able to write unit tests with JavaScript and TypeScript, etc., they're often quite painful to write. They often need an awful lot of things to be mocked out. By the time you've mocked everything out to make your unit tests work, you've pretty much mocked everything into oblivion. And it's really hard then to test proper UI flow. So, I started off my web development career using Angular 1 initially, which was very painful, but then Angular 2 came along, which is a lot better, and they had Protractor to help build those tests, but that was really quite hard work, just not developer friendly. And I think if you want to get developers to test their own stuff, you have to provide things that are friendly to developers. Otherwise, they just won't use them. But then along came Cypress, and then a bit later Playwright, and that pretty much solves a lot of these problems. Cypress and Playwright are really great solutions for writing very simple front tests on your front end. They solve a lot of the problems that we have with tests, with unit tests, and that you can write to test UI flow. I'm going to talk mostly about Cypress because that probably is the most adoption, or at least it's the most mature framework. But a lot of the things I'm going to say about Cypress are still hold true for Playwright. It's largely the same thing. It solves the same problem. It looks very similar. So I don't know if everyone here has used Cypress or not, but I'll go over it anyway, just in case, just for a refresher anyway. So Cypress lets you build a bunch of tests, and each test basically drives the UI. It drives the UI through the DOM, but in a very convenient way. So in this case, actually, these are genuine tests from Cypress at Cykubed itself. So I'm testing the table here. I'm going to a particular page, and I can actually intercept. I can mock my API fixtures, which means I'm not dependent at all on an external server, which means my tests are very quick. And also it means I'm only testing my UI, which is great. I'm not testing my UI and my servers, which sometimes is what I sometimes want to do that, but often I don't. Cypress has a very neat built-in feature of auto retries. So websites are asynchronous, things happen, and A depends upon B depends upon C. Because Cypress runs inside the browser, And because it has an auto retry built in, it means that you can actually write your tests as if they were written in series synchronously. In practice, they're actually asynchronous. And Cypress abstracts a lot of that away. It handles the asynchronousness stuff for you. So you don't have to worry about it. You don't have to have waits or complicated nesting. It's just handled for you. So it's a great tool for writing tests. It's very convenient for writing tests. It makes it quite easy to build up a large regression suite of tests, which is fantastic. Downside is, well, actually, so because of some of these are the type of speeches I've talked about, very friendly syntax, real-time testing. When you write your tests, that pane on the left there automatically updates, so it automatically reruns the tests, automatically generates screenshots on failures, lets you mock your APIs. The downside is it can be quite slow and expensive to automate. You can automate it on any CI/CD platform will let you run this. It is really just Cypress run. You can do that, but it tends to be very resource intensive. If you want to run the tests in parallel, particularly with Cypress, you will actually need a subscription to Cypress.io in order to run them in parallel, which isn't cheap. Generally, most CI/CD platforms like GitHub, GitLab, Bitbucket, they have a one-size-fits-all approach to reporting the results. And that doesn't really mesh terribly well with things like Cypress. So, it's not a very convenient way to spot fails, to view screenshots. It's generally, quite unfriendly. And to be honest, even the Cypress.io website is still a bit unfriendly. And it's often very expensive to run. You will run out of your 3 minutes on most CI/CD platforms very quickly. Now, I'm actually going to go straight into the demo now, and I'll go back to some of the rationale behind Cykubed. Now, this is when I hope I'm not attacked with the demo gods. So it should all work, but let's see. Let's find out. So I'm going to change my share, and see, and I will share my desktop. There we go. Right, so that should be sharing my desktop, if everyone can see that. Yeah, that looks good. So here's Cykubed. So Cykubed is an attempt to scratch that particular itch. Basically, I was using Kubernetes in previous companies a lot for back-end deployment, and I was running the tests in, at the time, Bitbucket pipelines. And it was incredibly expensive and incredibly slow. And I thought there must be a better way to do this. Hang on, I'm using Kubernetes for the back end. Why can't I run Cypress tests on that? And Cykubed was born. So Cykubed is a way to make it very easy to run your Cypress tests on your own your own Kubernetes cluster. So I'm going to sign in. I'm going to dive straight into this. So I'm going to sign in with GitHub as me. Well, since I've signed up, well, I've indeed. I authorize myself. And I give organization a name. Now, there's two choices. I can either host in your own cluster, which is what I'm going to demo today, or if you want an even easier approach, you can actually host in Cykubed clusters, which means you don't need to run any Kubernetes, and that's a pay-as-you-go basis. But the most bang for buck here is definitely hosting on your own cluster. That's why I built it in the first place. So let's go for that. We can integrate with Rocket Chat and Slack. Let's integrate with Slack. I'll choose the right workspace. That would be this one there. Yeah. And I'll choose the channel, which is demo. Let me just send a test message. Yep, there's my test message. So that all works. I'm going to actually be notified on everything. You can configure it so it's only notified on fails and flaky tests, or when you've just fixed something that failed. But for the moment, we're going to do everything. So let's create that. And we'll try for the free option. Okie dokie. So now I'm going to install an agent. So we'll pick the platform. I'm going to host this on Azure. The main reason is Azure is very generous with its free credits. So for startups, it's quite a good idea. And it supports Spot VMs, which I'll come on to later. So the installation is really quite straightforward. I'm using Helm to actually install everything. So actually, all you need to do is copy and paste these into a terminal. Just uses kubectl exactly the way you would normally do for any Kubernetes cluster. This is all absolutely standard Kubernetes things. You just need to install Helm and have access to a Kubernetes cluster, and the rest is all just this. So we'll do that. We'll kick that off, and that will go away and install it. And a few minutes later, this will actually pop up as connected.
One question.
Sure.
I've used Helm, but is it agnostic to the OS, or can?
Yes.
Okay.
Yeah, it should do. I mean, I'm using this on Linux. I'm pretty sure it works on Mac and Windows as well. It's actually just the wrapper around kubectl, so it's connecting via. It doesn't require anything in the cluster. It's just connecting via the APIs. So it should work anywhere, I think. I've not tried it on Windows or Mac, but I have no reason to think it should work.
Okay, thanks.
And there you go. That's connected. So this is actually connecting back via WebSockets to my API, the API servers, hence the greenness. So I will. Let's link it to my GitHub project. So I have a GitHub project. Actually, it is actually the Cypress web app itself, but with a lot more bogus, with a lot more tests. So I've copy and pasted the test to make it more interesting demo. So let's say, okay, that's the demo app. We're going to test Cypress. Actually, it has also detected that. I'll use just the Electron browser that's built into Cypress. Generally, a lot of we were trying to auto detect as much as possible. So actually, you could click create now and this would work. But I'm just going to go through the features anyway, just to point them out. So we're going to use node 18. It's auto detected. This is an Angular application. It's assuming this is what you need to do to build it, which is the standard. And that's the port you serve it on. I'm going to run 8 runners at once because why not? We'll retry twice if it fails. And because it's running on your own cluster, you can define as much CPU or memory as you want. If you have a particularly complicated app, maybe you want to give it more memory, the defaults will usually be fine. So let's stick with these defaults. And that will go away and create it. And there we go. It's kicking it off. And I added a deliberate failure into one of these tests, which actually is this here. So actually, this should say 1. I've actually changed it to 5. So I'm expecting this one test to fail. Now, the reason I kicked this off earlier in the talk is because this can take some time to run because, actually, it's running quite quick now. Because sometimes this yarn install can take some time because you're installing packages from scratch. The second time around, this is quicker because actually it caches the node modules. So the second time around, any subsequent builds should be quicker. Now, so while that's kicking off, I will actually just switch back to the demo. And let's just see if I can, there we go, and share screen. There we go. Right, back to the demo. So just go back to why did I do this in the first place? As I said, I tend to work in startups, and at the time we were using Bitbucket for everything and Bitbucket pipelines for all our backend tests. And so we thought, okay, let's run Cypress in there using Cypress Run. That should work, shouldn't it? And it did, but it's incredibly expensive. And in fact, if I'd done some analysis there based on, let's assume we have 10 developers pushing twice a day. Actually, this company I was in was worse than that. Let's assume we have 200 tests and the whole thing takes 60 minutes to run. Your monthly costs will be those. And this is just to run the tests. This isn't actually to run them in parallel. These are just running in series. And actually, sometimes also because certainly with Bitbucket pipelines, occasionally we would just run out of memory towards the end, and then the whole test is invalid. So it wasn't a great solution. We had to actually restrict how we used it and only do it in certain branches. And so you didn't really get the most benefit from this. And that's when at the time I was thinking there must be a better way to do this. Why not use Kubernetes? So what are the advantages? Well, it can auto scale. Kubernetes will actually, Kubernetes cluster can start at 0 and scale up to whatever you need to scale up to, and then scale back to 0 again. So when you don't use it, you're not charged. You can use any combination of CPU and RAM you want. It costs the same. By and large, it costs the same to run 4 CPUs for 100 minutes as it does for 400 minutes from 1 CPU. Based on whatever quota your underlying Kubernetes platform will grant you. So if they grant you a sufficiently high quota, you may as well just use all your CPUs and just get your tests run quicker. If you run this in the CI/CD platform, they tend to be much more restrictive about the amount of parallelization you can use. If you have a particularly complicated app, you can use more memory. It's your cluster, it's your state. You can use whatever you want. Kubernetes supports volume snapshotting, which is great if I want to take snapshots of my node modules, say, and reuse them later on, because that's quite a slow operation. If I can take a snapshot of that and reuse it really easily, then that's great. That solves my problem there. And it can make use of Spot VMs. Now, Spot VMs are virtual machines that are up to 70% cheaper than the normal virtual machines. They are not supported in all platforms, but certainly they're supported in the main ones. GCP, Azure, and AWS all support them. The downside is you're not guaranteed. It's possible that under certain loads, a Spot VM may be you may be evicted from a Spot VM. You're still given notice. You're given, say, 30 seconds notice, and then you just have to find another VM. But for testing workloads, it's perfect, because fine, if we're running, Cykubed is running tests a file at a time. If it turns out the Spot VM is evicted, well, that's fine. We just deal with that, return a test to the queue, pick another VM. So it's great for this kind of workflow. And Kubernetes is in theory cross-platform, as in I should be able to run a Kubernetes configuration, a set of, it should work on any Kubernetes cluster on any provider with no changes. In practice, there are slight changes to do with generally around what storage classes various platforms support. For example, Google GCP supports a read-only many storage class, which means you can actually have multiple pods reading from the same volume. Unfortunately, most of the other ones don't. So there is a slight change in that at that level, but by and large, they are agnostic. So it's actually a great fit for Cypress and running these kind of tests. As I said, I did some analysis on the costs before I embarked on this. Okay, what is the difference between Spot VMs and normal? Again, using the same thing, 10 devs twice a day, 200 tests, 60 minutes in total. Let's assume we use the East Coast of the US because that tends to be the cheapest. And Spot VMs, if you remember before, it was at the most cheapest one was $150. This is $22, so a lot cheaper. If you use GCP or Azure, you won't actually get charged per cluster. You only get charged in GCP for your subsequent clusters. So if you have 2 clusters, you get charged for the second one, but not if you've just got 1. So very cost-efficient way to run VMs. I'll come to how it works in a bit. So let me just go back to the test, because the demo, because actually it's moved a bit further on. Let's see. Desktop. There we go. And that's correct. Okay. So we can see here that actually it's now built the node modules, which is great. And it's built the app. It's a downloaded Cypress. This again only happens once, and it's cached from now on. Now this is all just using standard Kubernetes infrastructure. So it's using things called jobs and volume snapshots. So actually we can see this in action if we want to do, it's actually Cykubed demo. Namespace is Cykubed demo. This might be quite small text in terms of here, but you can see here actually it's creating, I think, did I say 8? Yes, there are 8 different it's called pods in Kubernetes parlance at once, because a Kubernetes job, it just supports parallelization built in. So if you want to run the same thing n times, it's just part of the spec. So that's what we're doing. We're running the same thing n times. So what I've done here is we have built the application, in this case, an Angular app, cached it, so I can use it the next time, then creating these 8 pods. Think of them as kind of like, if you don't understand, if you haven't used Kubernetes before, you can kind of think of them as virtual machines. They're not quite, but they, in practice, can think of this as the same thing. And each of them is doing the same thing. Each of them is running a web server, running a single page app of, in this case, the Angular application, and then running tests. And it's pulling, we have 15 files, and it's pulling each one of these at once and running the tests in those files. And when it's finished with that, the runner then picks another file and another file until it's finished, then it quits. And the nice thing about that is when it's quit, if your Kubernetes cluster will then just scale back to 0 again. See here, there we go, it's scaling up. And it's running the tests. Now, one of these should fail. This one in particular should fail. And what should happen then is we should get a notification in Slack, which will link off to this. So let's see, they should start to pass in a minute. This part of the actual demo is quite quick. So actually, in order to actually run the test is quite quick. It's just the build in the actual application. And unfortunately, that's because of Angular. There we go, there's the first pass. So on. Now, and there's our first failure, jolly good. Now, what Cykubed also integrates properly with GitLab, GitHub and Bitbucket pull requests. So actually, when this is finished, then we can have created. If I say, well, okay, here's the bug. Well, let's fix this bug in a different branch. So let's have a new branch, which is the fix of this bug. And in this branch, I'm going to say, well, that should have been one in the first place. So let's do that, and let's do that. And when this is actually finished, I'll commit that, and then we'll see it should have fixed it. Any minute now, this should finish. Let's see here. Here are the pods finishing what they're doing and just disappearing. There we go. Failure. Playing up. Oh dear, we got a demo strikes again. Come on. There we go. Sorry, I think it was zoomed in funny things. So that's the failure, and it's telling me exactly what it failed. It failed there on that line. So I've got immediate feedback on where it failed. And if I go to demo, I can say, yes, there you go. It did indeed fail on that branch. We have 1 out of 68 tests fail. And if we can see the screenshots where they failed, because we're retrying 3 times, we get the same screenshot 3 times. But that is the fail. You can run this on multiple browsers. So this is only running on Electron, but you can actually run it on as many as you want and then test all in parallel. Okay, so let's fix this, shall we? So let's create a branch for this. And in this case, we're going to fix this bug. And I will commit that. Fix this bug. I'm going to create a pull request for this. Not that one, sorry, wrong one. Pull request. Pull request. It's the wrong way around. Nope, it was the right way around, sorry. Let me try again. New pull request. There we go. Right, it's Python. We can see here it's actually saying we're queued or waiting to run this test on Cykubed. And in fact, if we go back to there, you can see there's the test. And this time around, it should use the node modules that we previously cached and run the test a lot quicker. Let me just switch back to, while it's running this, I'll switch back to my presentation again. Let's see. Okay. Slides. What's the slides though? So that was the rationale behind building this. It didn't really exist, and I wanted it to exist, and so I built it. So more details on how it works. So what we do when I installed ran that Helm command, that was installing an agent, which is just a single a Python application, or rather written in Python, into the cluster using Helm. That then talks out to our Cykubed API service via WebSocket. So it connects via that, which means you don't need to expose anything in your cluster. It just stays within your cluster. You don't need to muck about with firewalls or anything. Well, as long as you allow in start.cykubed.com. Cykubed then talks to your Git provider, either via an app integration in the case of GitHub, or via webhooks in the case of Bitbucket and GitLab. And so when anything changes in Git, that will get the API servers will be kicked. They will then tell the agent, please kick off a run for this particular SHA, for this particular commit, and tell me when it's finished. Upload any screenshots into the cloud so I can see them. In addition, for things like GitHub, it also integrates with GitHub's checks, so you can see when it won't let you merge the pull request if the tests are failing. And the same for, I think, and the same for Bitbucket. It integrates properly with Bitbucket's pull requests. It's all just using standard Kubernetes things. So uses Kubernetes jobs with a capital J that's to run, when we saw it build in the Angular application and then actually running the Cypress test itself. It is just running, it is just building the application the way, with the ng build. And then it's running the tests, well, actually with Cypress run. So it's just using standard Cypress run -s, the name of the file. But because of the built-in parallelization, if you want to run 8 at once, it can happily run 8 at once. And when it's finished, it will just quit. In order to store the working copy, so when you built the actual application, that's using a thing called in Kubernetes parlance persistent volume claims, which is very wordy, but effectively it's just the volume, persistent volume. And we use volume snapshots to cache the node modules. So for the subsequent tests are quite quick. As I mentioned earlier, it would be lovely if all Kubernetes platforms were the same. They're not quite. Some are better than others. GCP is probably the best of the bunch, unsurprisingly, given the amount of input they have into Kubernetes. Amazon's probably the worst, because it's quite a bit more painful. For example, auto-scaling isn't easy and doesn't really happen out of the box. You have to do a bit more work. Azure is somewhere in the middle, but Azure is still pretty good. And probably in terms of cost, Azure is probably the most cost effective. GCP has a thing called Autopilot, which is, I'm not using for this demo, but actually the nice thing about Autopilot is you just pay for what you use. You don't, it's like Amazon Fargate. You just say, give me this much CPU, this much memory, sort it out, please, Google. And Google does that for you. So actually GCP Fargate is probably my preferred solution. I'm not using it for this demo because it can take some time to scale up. We should make the demo a bit slower. So, right, I think my demo is about to kick off again. So let's change that back to that again. There we go, back to the desktop. Yep, there we go, it's using that. So you can see here, it's a lot quicker this time around because it's using the cached node modules, which is great. Still has to build the node application, which with the Angular application, sorry, which of course Angular isn't terribly quick. But now it's about to kick off, and you can see here it's creating the runners. So this time around, hopefully everyone thinks should pass. And then we'll get a nice message on Slack to say, yep, everything passed, we're all happy. And then the GitHub will say, yes, you're allowed to merge because you fixed the bug. Let's see, I'm new there. This is the nerve-biting part of demos with Kubernetes, because there is some kind of, it's not always as quick every time. Sometimes it's quick, sometimes it's slow. It's still usually quicker than a CI/CD platform. Well, it almost certainly is, because you're running in parallel. But sometimes the time to actually kick things off can vary. You can see here, that's running. Yeah. The other feature, some of the things that Cykubed does, which you don't necessarily get for free if you're running this yourself, is it automatically detects flaky tests. So these tests, I'm actually making them fail. Actually, in some ways, failed tests are easier to work with, because usually they reliably fail, and you know why they failed. The worst kind of tests, the ones that pass occasionally, fail and then pass, flaky tests. It's quite easy to produce a flaky test in Cypress and Playwright if you don't know what you're doing, or even if you do know what you're doing, it's still quite easy. And they're often very hard to debug because you can't often spot them. So Cykubed will spot them for you. It says, okay, a flaky test here is a test that by definition has initially failed and then passed. And so we will automatically detect that. I'm not expecting that here. These should all pass any minute now. Probably about another minute, actually. Let me just, there you go. That's happily passed in. Back to the presentation. So as I said, this is just using standard Kubernetes things, which means in theory although we support 3 platforms at the moment, there is in principle no reason why we couldn't support any Kubernetes platform, as long as they support volume snapshots, which pretty much 99% of them do. So just overview of some of the Cykubed features. As I said, it supports GitHub, GitLab, and Bitbucket. Integrate natively with GitHub and Bitbucket pull requests. It's a very simple UI. It's purposefully very simple. It just tells you what you want to do, and that's it. So there's nothing. It's mostly about just spotting tests and outlining what's failed. Because as developers, that's what I want in my day job. I want just to know, right, what's failed, show me the bug. It integrates with Slack and Rocket Chat. I didn't know about Rocket Chat until I started this project, but actually it's quite nice. It's basically a free Slack. So you have full control over your resources. You can run tests of multiple browsers. Cypress by default doesn't support this yet. Playwright does. So, but it's actually in Cykubed, it's quite easy just to run tests on as many different browsers as you want. There's a full API. In fact, the website, the Cypress app, actually uses the public API, nothing else. So everything that the Cypress app does, everything the Cykubed app does, well, you can do because it's the same API. And there's outgoing and incoming support for webhooks. And the reason I built this in the first place as a cost-conscious Yorkshireman is because it's very cost-effective. Actually, in the test just passed. So there we go. Let's go
Nick,
back.
before we move, there is one question, if you want, in the chat.
Yep. Oh, sure. Where's that? I've lost the chat. Chat, found it. There we go. Okie doke. the way parallelization works in Docker is if you not a Docker, in Kubernetes is that Kubernetes jobs are a thing which will run a Docker image to completion. If you specify the parallelization, it can default to 1. It defaults to 1, but you can set the number of the parallelization to whatever you want. So if you have a Docker job with parallelization set to 10, it will run that image to completion 10 times. And so in this case, because each one of those images is simply doing exactly the same thing, which is pulling a file at a time from a queue, once it's finished pulling from the queue, it exits. So because of that, you can run as many as it doesn't matter how many you run. I mean, we tend to we'll never run more jobs than there are tests because there's no point. But it will run as many as you need to run, pull a test at a time, run Cypress run for that entire test file, pull the next file if there are any files. If not, it will just exit. So does that answer your question? Cool. So there we go. The tests have passed. Jolly good. That was the test I just did. The bug I fixed. If we go to the channel, we can say, yep, that's passed. That's passed again. I don't know why that couldn't give me 2 there. That's probably what I did earlier. And the pull request says, yeah, all the tests have passed. Great. You can now merge away. So I can now merge the fix. And if we go back to the dashboard, we can see that, yeah, there we go. There's the fail, and there indeed is the fix. And that is then sent a message to Slack. If I click on that, it will actually have taken me into the fail in the first place. There we go. And that's largely it for Cykubed. It said it does one thing, but tries to do it very well, which is just make it very, very simple to automate your Cypress and Playwright tests in a Kubernetes cluster. As I said, if you don't have a Kubernetes cluster, you can still use Cykubed because you can use our hosted option where you just use the Cykubed clusters themselves. We charge you for it, and you'll be charged more than you would if you were just doing it yourself. But it's quite, if you want to just test it out and see if it works for you, it's a very easy way to get started. But also, it's very easy actually to set up a Kubernetes cluster. Certainly, if you use Google, GCP has a very, very friendly user interface for creating clusters. If you create an autopilot cluster, it's pretty much a few clicks and you're away. And Helm is pretty straightforward. So let me just go back to my. Well, that setup is what I've just done. It's literally copy and paste. It's, I've gone from scratch from a cluster which is empty. There's nothing in this Kubernetes cluster. Well, actually, there is. There's Kubernetes. Cykubed is running in this cluster, but you can work on an empty cluster, and you just copy and paste the commands I showed you, which it's in the setup into a terminal. That's it. That's all you need to do to set it up. The reason I did it like that is because often in a lot of these CI/CD platforms, you have to hunt around, find the config in YAML and test it, and then it fails, and you have to test it again and tweak it again, and it's just fiddly. And I really didn't see the point in that. So actually, I tried to make this as simple as possible. So actually, the only thing you tend to actually need to change when you're setting up a project in here is telling it, how do I actually build the application? If it's Angular, we make an attempt to auto-detect it. So if Angular view next, etc., we'll make an attempt to say, okay, I know what this thing is. I'm going to do a shallow clone and see if I can work it out. GitHub Actions works. I mean, it's another way to do this, but GitHub Actions is slower, more expensive, harder to run in parallel. You have to hunt around and find the relevant bit of YAML to install and make sure it all works. And the user interface, at the end of the day, is okay. It's not too bad, but it's not particularly pretty. It's not terribly, it's not the problem with a lot of these CI/CD platforms is that they're one size fits all. They're designed to do anything, but because of that, they're not specialists in any one thing. So the argument against using them is it's a damn sight cheaper to run inside your own cluster. It's really easy to set up, and you can run in parallel as much as you want. If you've got a 280 test and you want to run 100 CPUs at once, as long as your Kubernetes provider will let you do that, and usually if you ask for more quota, they'll grant you it, then you can do so. And you can't really do that in GitHub Actions or Bitbucket pipelines or GitLab or any of the other kind of things. Let me just actually, any more questions on the demo itself? I've got a few. Well, I've got one more slide. How many more slides have I got? Actually, this is my last slide. So yeah, actually, if anyone has any more questions they want to ask on the demo while I'm here, feel free to fire away. Otherwise, I'll head back to my last slide. Okay, let me head back to the slide. There we go. That's the slide again. There we go. So just to reiterate, as I talked about, those are kind of the features of Cykubed. It's a replacement effectively for GitHub Actions, but it does integrate with GitHub Actions, or it can do, because it supports. Actually, sorry, I'm zipping about a bit. Because I support webhooks, and it's got a full API. Actually, it's very straightforward to integrate with any other system you want. So we can add a new webhook, and let's say, whatever, my webhook. Hook. So whenever a test does any of these things, let's say that, let's say for all projects, I'm going to post something to this webhook, and it could be any arbitrary URL. And so that will hook out the other way as well. So if I want to integrate with on the outgoing webhook when things have passed or failed, I can do that. Alternatively, I can just use my API. So there's my API. The documentation is there. Using lovely redoc. And as I said, everything, if you run this in Chrome Debugger, you will realize that these are all these APIs. So everything there is nothing private. Everything that's used in here is used here. So you can pretty much do anything you want. You could, in fact, you could build this app again if you wanted to, because the APIs are all here. I think that's, I haven't got anything else. Webhooks notifications. So they integrate with Bitbucket, GitLab, Rocket Chat. That's all pretty straightforward. You can use as many as you want. It's fine. It works with all of them. You can run as many agents as you want. You only really need one agent per cluster, but there's nothing to stop you running for multiple clusters. But you tend not to need to. The agent itself is very lightweight. And in fact, I can show let's see. Slide here. Oh, there we go. Different page. So this is running in Azure, as I said. For the purpose of this demo, I've actually also scaled it up to a minimum of 3, but it will work perfectly well if you just say, no, I want to start with 0. This is now going to go away and scale this down again. And when you need to, when it wants to run the tests, it will just automatically scale up to as many as you need to scale up. The agent is minimal. It hardly requires anything at all. So it won't cost you very much to run. And that is pretty much it for my Cykubed demo. Let's see, back to the slides, if I can find them. There we go. And just to reiterate, those are all the features I just talked about. And I'm more or less in time, so how about that? I think I'm done. Over to Q&A really now. If anyone's got any more questions, feel free to fire ahead. you want to stop screen sharing? Oh, oops. Question? Ah, yep. Indeed, there is a free tier. You can have a full version for free. I don't like limited free trials. I just think they're a bit pointless. So there is a free, the free tier of Cykubed is you can use a certain amount of limit. You can get it basically is based on number of tests. Similar to Cypress.io, it's based on the number of individual tests. So there's a certain free tier, which is I have to remind myself what I said as the pricing model. I think it's like 1,000 tests. Yes, 1,000 included tests, which you can use for free. In fact, let me just share the pricing. There we go. Share. And I should also argue this is still early days with the pricing model. So, but this is it's aimed to be. I don't want to be a disincentive for people to write more tests, and an awful lot of pricing structures seem to disincentivize you from writing lots of tests, which I hate as a developer because we should write lots of tests. So for free, you can use Cykubed. For 2 users, you can have 1,000 test results, which is the IT clause. You can use the fully hosted option if you don't even want to run a Kubernetes cluster. That works in the build credit system. So it, 1 CPU is 10 build credits, 1 gig of RAM is 1 build credit. You get 1,000 build credits. You can run up to 4 tests at once. The step above that is here, which is the starter plan, which is where you allow 5 users, 20,000 test results. So really quite generous, a lot more generous than Cypress.io. And then everything from then on is incremental of $5 per every 10,000 tests. It's an it clause. So, you know, basically the same as Cypress.io, so an it clause. And in fact, well, the learning curve to use Cykubed should be almost nothing. The learning curve for Cypress and Playwright, okay, that's a bit more. But actually, Cykubed is pretty straightforward. I mean, you can see I started from scratch and I installed it in, what, 3 minutes? And most of the time, really, as developers, you kind of want to stay in, if you're using Slack, you want to stay in Slack. And then when you get a fail, you want to click on the fail and see what's failed. And so that's what Cykubed does. So there's really not much to do. It's a good Kubernetes citizen. It will clean up after itself. So I would say not much at all. No, not yet. It's certainly on my my roadmap is to consider doing dashboards. There is a limited amount of sorry, there was this of obviously we've got a per test run result. I am considering doing more dashboardy type things, which is you know, viewed over time, particularly will be useful for flaky tests. Because sometimes your flaky tests are so flaky that they may only show up 1 in 5. So actually, in that case, having a thing that works over time would be quite useful. Really, for this, I'm looking for feedback. It's certainly something on the roadmap. So I'd love to get some early users to give me some feedback on this. Yes, test run results are stored. Well, actually stored. They don't time out. So they're stored forever. The actual images, the screenshots, there's a limit, there's a time limit before they are archived. But it's quite generous. I think it's something like 2 months. But yeah, they're stored as long as you want. So of course, you know, that means the data is still there. If we do want to build dashboards in future, it would still work with your historical data. And there are some stats for the amount of CPU, memory, and ephemeral, which is the ephemeral storage. I don't actually charge for storage per se. Back in tests. If you trigger your tests, well, yes, via the API. I mean, the API here is, these test results here are really just from test run, gets test from detail. It's just this. So everything you can see in the app, you've got from here. So it's, you know, with one function call using the API token, you can simply get all this information back and do whatever you want with it. This is the JSON blob. Yes, you can do. It's been around for a year. I started building it a year. A bit more than a year. I started building it a year and 3 months ago, so 9 months ago. So quite new. It only really came out of beta in the last couple of months. But I've been using it on my companies, my projects. You know, for the past 6 months, it's been rock solid. It's been fine. It does exactly what it's supposed to do. Thank you. The thing that came up recently also is Playwright. I originally started, I mean, you can probably tell by the clue in the name that it started off as just Cypress, because mainly because the costing structure of Cypress.io so annoyed me, I had to build something. But then Playwright came along, but so actually does now support Playwright as well. And it's largely the same. There's not a lot of difference really. The way one instantiates tests in Playwright is slightly different, but essentially it's still doing the same thing. It's pulling a file at a time, running the tests, pushing the results up. If you run on Google Compute, it will also tell you how much it costs. I haven't worked out the APIs to do that on Azure yet, so it doesn't do it here. Any more questions? As I said, I am really looking for some good early feedback. So please try it out. The free tier should mean you can try it out with no pain. If you do have problems, please get in touch with me, because I have an awful lot of experience in Kubernetes now, rather more than when I started this project. And so I can help you if you get stuck, or indeed if you have any feature requests. Any more questions? No? Okay. Well, I think we're probably done then. Hang on. Oh, there you go. No more questions? Excellent. Well, thank you everyone for turning up and listening to my talk. I've been Cykubed. Feel free to have a play. Please give me some feedback. It's I said it's a young tool. It's early days, but I built it as a developer for developers, and I'm very keen on just making this work. Okay, I'll stop the screen share now.
Thank you, Nick, for the great presentation. So I will share my screen now. Okay. Do you see the screen? You see my screen, guys? Yes. Okay, cool. So thank you, Nick, for this super nice presentation. And I would like to speak about the next CTM event, which will be in May, the 16th. And we will talk about a very trendy buzzword, AI model robustness and generalization testing with Advait. So please come. I think it will be very interesting. And that's it. Thank you all, guys. If you have any question, I've posted the Slack workspace, or you can find us in the continuoustestingmeetup.com, even on Twitter if needed. Thank you all.